Hi dear students, welcome to PMSH classes. This is the lecture 4 of motion in a straight line. And the topic we will be discussing in this video is uniform motion and non-uniform motion, instantaneous speed and velocity. These classes will be useful for students who are going to attend board examination, especially CBSE board examination and Kerala state board examination, and also for students who are attending competitive examinations like Team KVPY, NEET, JE, etc. Okay, so we will discuss the concept of uniform motion and non-uniform motion. So let us make two columns: uniform motion and non-uniform motion. Okay, so first of all, what is the word uniform means? You remember that the word uniform means constant. Okay, you have to remember that throughout physics. Okay, uniform means constant. Non-uniform means varying. Varying means changing. Okay, the value will keep changing. Okay, that is non-uniform. So uniform motion refers to bodies traveling with a constant speed or constant velocity. Okay, uniform motion means constant speed or constant velocity. That is, from the start of the journey till the end of the journey, the velocity of the body is not going to change. Okay, or in the time specified. When you are doing a numerical question, there will be a specific time specified. So from that start of time to end of the time, the body will not change the velocity. That is what is uniform speed. Okay. And non-uniform speed means it is the varying speed. The velocities will keep changing. The velocity or speed will keep changing its value. Okay. So in that case, we have some equations. We will come across all that equations at the end of this chapter. Okay. So that is the body is traveling with a varying speed or velocity. That is non-uniform motion. Okay, so we can say uniform motion. Here, the body travel with constant speed or constant velocity. And what is non-uniform motion? Here the body travel with a varying speed or varying velocity. Okay. So remember, we have told it is constant velocity or constant speed. Then what about the distance covered? Okay, if a body is traveling with constant speed or traveling with constant velocity, okay, then the distance or the displacement of the body will be equal in equal interval of time, isn't it? I will prove it using an example, okay? But just now understand that if the speed is constant or the velocity is constant, the body will have equal distance or equal displacement in equal interval of time. So we can also say another definition for uniform motion, that is the body have equal displacement or equal distance in equal interval of time. Okay. And what about here? The body is having, in a non-uniform motion, the body is having varying speed. That is, value of the speed or velocity keeps changing. That means the body cannot cover equal distance or equal displacement in equal interval of time. Or you can say unequal distance. The body cover unequal distance or unequal displacement in equal interval of time. Clear? So you can say the body have unequal displacement or unequal distance in equal interval of time. Okay. Okay. Now, if the speed is constant or the velocity is a constant, then the body does not have any acceleration. Till now, we haven't discussed what is acceleration or the concept of acceleration. Okay. Just understand acceleration means it is the change in velocity in a unit time. Okay. Within a unit time, what was the change in velocity? So constant velocity means the velocity is not going to change. Okay. So the change becomes zero, isn't it? Acceleration means change in velocity in a unit time. Okay. But uniform motion means the body travel with a constant speed. That is, there is no change. Hence, acceleration is zero. Okay. That is, acceleration equal to zero. So, in uniform motion, the body's acceleration will be zero. Okay. And what about this case? The body will have an acceleration. Okay. The body have an acceleration. Okay. So, I will tell you an example to understand this. An example to understand uniform motion, and also I will tell you an example to understand non-uniform motion. Okay, so let us consider a body and we mark the time and the distance traveled in a number line. Okay, so this is 0 seconds, 2 second. Let us make it equal interval. Okay, there is a gap of 2 second, 6 second, 8 second. Okay, now let us mark the distance covered in each of this time. At 0 seconds, the body have a distance 0 meter because the body is at rest. At 2 second, it have covered 2 meter. When it become 4 second, the distance covered became 4 meter, and similarly 6 meter and 8 meter. So let us calculate. Let us calculate the speed in each of this case. Okay. So when we calculate this interval, okay, what is the speed equation? We know speed is nothing but distance by time. Okay, speed is nothing but distance by time. So what is the distance covered? 2 meter. What is the time taken? 2 seconds. So 2 by 2, the value is 1. You know that the value is 1. Now let us consider this interval. Then it is, what is the distance covered in this interval? 2 meter to 4 meter. So the distance is 4 minus 2. That is 2 meter distance, isn't it? And the time interval is also 2 seconds. Clear? 2 second to 4 second means it is 4 minus 2. That is 2 seconds. So again the velocity become 2 by 2, which is equal to 1 meter per second. Clear? Similarly, you can consider any time interval. Okay, between any time interval, you will get the same value for speed, that is 1 meter per second. That means the speed or the velocity does not change. It is throughout the motion, the value is 1 meter per second. And you can see in equal interval of time, the distance covered is equal. First interval of time is 2 seconds and the distance covered was 2 meter. In the second interval also 2 seconds to 4 seconds, the time interval is 2 seconds, right? And the distance covered is 2 meter. So that is what the second definition says. that is in equal interval of time, the distance covered will be equal. Then automatically the speed becomes a constant and the motion is uniform. I hope it is very, very clear. Okay. Now we will go to an example for non-uniform motion. So we'll represent the motion of a body in a number line. Say 0 second, 2 second, 4 second, 6 second. Okay, I'm taking equal interval of time. There is a gap of 2 second in each interval. Okay. And at 0 second, the distance covered is 0 meter. That is the body is at rest. At 2 second, the body covered 4 meter distance. Then 6 meter. Then 10 meter. So let us calculate in each case. We'll consider the first. That is 0 second to 2 second. Let us consider 0 second to 2 second. So the speed will be distance covered, that is 4 meter, by the time taken, that is 2. So you get 2 meter per second as the speed. Now let us consider 2 second to 4 second. Okay, 2 second to 4 second. How can you calculate the speed? The speed is nothing but the distance covered. 4 meter to 6 meter means distance covered is 2 meter. And the time interval is also 2 seconds. So that is 6 minus 4 by 4 minus 2. That is 2 by 2. That is 1 meter per second. Now let us calculate from 4 second to 6 second. 4 second to 6 second. The distance covered is this one. 10 minus 6. 10 minus 6 by time interval is this. That is 6 minus 4. That is 4 by 2, which is again 2 meter per second. Okay, so what can you observe? From 0 second to 2 second, the speed was 2 meter per second. From 2 second to 4 second, the speed is reduced to 1 meter per second. There is a change in velocity. That is what I have told, there will be an acceleration because there is a change in velocity. Okay. And 4 second to 6 second, again the speed increased to 2 meter per second. Clear? That means it is a varying speed. So that is an example for non-uniform motion. And also you can have a visualization of the second definition. That is unequal distance in equal interval of time. Everywhere the time interval is 2 seconds. Clear? Everywhere the time interval is 2 seconds. That is equal interval. But what about the distance covered? At this interval, the distance covered is 4 meter. At this interval, the distance covered is 2 meter. Then the next interval, the distance covered again is 4 meter. So there is an unequal distance covered in equal interval of time. Then the body will have a non-uniform motion. Okay. So I have explained you every definitions and also I have cleared the concept of uniform motion and non-uniform motion. Okay. Now we will discuss the concept of instantaneous speed and instantaneous velocity. Okay, instantaneous speed and instantaneous velocity. So what you have to know, what is an instant, right? Instant means it is the time at which we say, suppose you are sitting in a car, okay, and you have started the journey. At 10:38, you are asking to the driver, okay, at 10:38 you are asking to the driver what is the speed right now. Okay, what is the speed right now? Then the driver will tell you some answers like 65 kilometer per hour or 40 kilometer per hour, something, right? So that answer is your instantaneous speed or instantaneous velocity. Clear? That is the at the instant we ask, at the instant of time. Okay, at what point of time we are asking, at that point what is the speed? That is what instantaneous speed. Okay, then can you observe this instantaneous speed somewhere practically? Yes, when you are looking to the speedometer of your car or bike or something vehicle, okay, you are looking to the speedometer. What you observe is the speed of that vehicle at the instant you are looking. So that shows the instantaneous speed. Remember, speedometer will show you the instantaneous speed, not the instantaneous velocity. Never say it is instantaneous velocity because speedometer does not show you the direction. Does it? No. It will show you the magnitude of speed. Okay, so you can say speedometer is an example for instantaneous speed. Speedometer is not the example for instantaneous velocity because no speedometer shows the direction. Okay, it only show the velocity, sorry, magnitude. Okay, so how can you define this? The speed or velocity of a object at any particular instant of time is called the instantaneous speed or instantaneous velocity. Okay, now let us consider a body starting from A and it traveled to a point B. Okay, if the whole distance for this motion is x, okay, if the whole distance for this motion is x, what you are telling is an instant, right? So at an instant, if the distance covered is very small, okay, very, very small, that you can say dx. Okay, if it is very small, you can say dx. Okay, then the time to cover that distance, very small distance dx will be small time only. That will be dt. Clear? Then how can you get the velocity? You get the velocity or speed, okay, v as uh, displacement by time, right? So you are considering an instant. Instant means the displacement is very small and the time taken to cover that small displacement is very small, that is dt. So it is dx by dt. So I hope the equation is clear. The equation is v is equal to dx by dt. The equation is v is equal to dx by dt. Okay. And you may please note that speedometer of vehicle shows instantaneous speed. Okay. So about this equation, v is equal to dx by dt, it is a very important equation and there are some meaning other than this instantaneous speed and instantaneous velocity to this particular equation, that is v is equal to dx by dt. We'll come across all that physical and geometrical meaning and also the mathematics to do dx by dt. Okay, that is basically differentiation. And we will come across all that in the upcoming lectures. Okay, so if you like my videos and if the concepts are clear to you, then please subscribe the channel and also you may like it and you may share it to your friends. Okay, so in the next class we will be discussing about graphical analysis. Okay, that is a very important topic and it will help you to do or understand the graph that is going to come not only in this chapter but also in the whole physics. Okay, so see you in the next lecture.